What if I told you the most harrowing childhood ever to evolve on land didn't belong to a predator, but to a baby Brachiosaurus? The egg was scarcely bigger than a soccer ball. The hatchling weighed 2 pounds. Within 15 years, it would top 80,000 pounds. To bridge that impossible gap, a calf had to endure a gauntlet of predators, flash floods, and its own neck growing so fast it could barely lift its head. Only a fraction survived. Tonight, we're going back 150 million years to follow one of them. From the moment it breaks its shell to the day it finally towers over everything. But this isn't a story of monsters. It's the story of a child. A child born into the most unforgiving nursery Earth has ever known. 150 million years ago, in the lush river valleys of what is now North America, Brachiosaurus ruled the forests. A fully grown adult stood 50 feet tall, weighed close to 40 tons, and could strip the crown of a conifer with a sweep of its neck. But the calf we're following started life smaller than a house cat. Her mother, having laid up to 30 eggs in a shallow scrape, simply walked away, never to return. The hatchling would enter the world alone, with no parent to guard it, utterly defenseless. And the Jurassic was filled with eyes that had already learned to spot an easy meal. Allosaurus, Ceratosaurus, massive crocodilians, all perfectly adapted to hunt the small and the slow. The statistics are brutal. Paleontologists estimate that 85% of Brachiosaurus calves died within their first 18 months. That's not a typo. Nearly 9 out of every 10 never saw their second year. If you were a Brachiosaurus calf, the odds were stacked against you from the moment the shell cracked. You were born into a world of giants, but you were not one of them, not yet. The forest floor was a tangle of ferns and horsetails, but also a labyrinth of ambush points. Every shadow could conceal an Allosaurus. Every puddle could hide a lurking phytosaur waiting to drag you under. The first few days were the deadliest. Your only defenses were camouflage and speed, neither of which you particularly excelled at. You had to learn to read the silence of the ferns, to know when the breeze shifted and the insects went quiet. And you had to eat, constantly. Growth was your only escape from the jaws of the predators. But that growth brought its own nightmare. The only way a calf could survive was to grow, and grow impossibly fast. At its peak, a juvenile could pack on 3 kilograms a day. But that rapid growth created its own lethal risks. Bones that couldn't keep up with muscle, necks that became so heavy they literally snapped under their own weight, infections from puncture wounds that festered without a mother's tongue to clean them. So how did any of them ever make it? What secret did the survivors possess? Tonight, we're going deep into the fossil record, into the growth rings of ancient bones, to walk beside one calf as she navigates the gauntlet. Her first breath, her first enemy, her first miracle. The journey starts right now. The shell is warm, warmer than it has ever been. For 65 days, the egg has lain buried in a shallow mound of rotting vegetation, the Jurassic sun baking the upper layers while the ferment of cycad fronds and fern leaves generates its own slow heat from below. Inside, the embryonic Brachiosaurus has been absorbing the last of the yolk, its tiny lungs already breathing the thin air that filters through the porous shell. And now something is changing. The heartbeat that has pulsed steadily for weeks quickens. The cramped space, once a sanctuary, becomes a prison. A blind, unreasoning instinct fires through the hatchling's nervous system. Break through. Break out. Now, the egg ruptures from within, not with a clean crack, but with a split that travels upward as the calf thrusts its 2-pound body against the inner membrane. Its head emerges first, eyes still sealed shut by a protective film, nostrils flaring as they encounter air for the first time. There is no mother's tongue to clean the hatchling, no gentle nudge of encouragement. The calf is entirely alone, It thrashes in the damp cradle of its collapsed egg, coated in the sticky residue of albumin, and drags itself free of the shell fragments with spasmodic kicks of its back legs. The effort is immense for a creature whose bones are still soft cartilage, whose muscles have never been tested, but the drive to move is absolute. The nest is a death trap. The scent of fresh hatchling has already begun to seep into the forest air, and the forest air carries it to noses that know exactly what that scent means. Around the hatching site, the world is enormous and green and humming with hidden hunger. The nest, a circular depression scratched into the sandy loam of a riverbank, contains the remains of perhaps 24 other eggs. Most are silent. Some are shattered. A few still hold a faint warmth. But the calf does not linger to discover whether its siblings will ever stir. Its first wobbly steps take it away from the nest, toward a dense wall of ferns that rises like a green fortress at the edge of the clearing. To a creature the size of a squirrel, a fern frond is a ladder into a cathedral. The calf pushes through the lowest fronds, the damp leaves sliding over its back, and disappears into the understory. It does not look back. It will never see the nest again. The first hour of a Brachiosaurus calf's life is a blur of sensory overload. Every shadow flickers with threat. Every airborne scent is a possible pursuer. The forest floor is a labyrinth of mosses, liverworts, fallen cycad cones, and the feet of larger creatures that have passed through, leaving trails of trampled vegetation wide enough to be highways for something the size of a newborn sauropod. The calf follows no path. It moves by instinct alone, drawn to the darkest, thickest cover available, where the sunlight barely penetrates and the ground is soft and cool. It does not know that this instinct has been refined by 100 million years of predation, that its ancestors who moved toward open ground were the ones who vanished from the gene pool before they could lay their own eggs. It simply moves, and the moving keeps it alive. By the time the sun reaches its zenith, the calf has found a hiding spot beneath a fallen tree fern whose trunk, rotting and moss-covered, offers a narrow cavity between the wood and the soil. It is just large enough to accommodate the calf's curled body, and the calf, exhausted beyond anything its 2-pound frame has ever endured, sinks into a torpor. For the first time, its heart rate slows. Its brain, still nothing more than a primitive processing organ for sensory input, begins to log the sounds of the new world. The drone of giant beetles, the whine of insect wings that belong to dragonflies the size of hawks, the distant, low-frequency rumble of something very large walking very slowly. The calf has never heard an adult Brachiosaurus, but its bones carry a memory of the sound, a vibration that feels like safety, even though safety is not a concept. Its brain can form. It sleeps, and while it sleeps, the clock starts ticking, because growth, for a Brachiosaurus, is not a leisurely progression. It is a biological imperative that begins the instant the first mouthful of plant matter is swallowed. The calf wakes at dusk, not to conscious thought, but to a hollow, driving emptiness in its gut. It must eat. The calories that fueled its escape from the egg are nearly gone. If it does not find food within the next few hours, its body will begin to consume its own muscle tissue. For a creature on the lower rungs of the Jurassic food chain, that is a death sentence. Weakness is detected. Weakness is exploited. Weakness is corrected by the ecosystem with ruthless efficiency. The calf pushes out of its hiding place and begins to sample the vegetation around it. Its needle-like teeth are designed for one purpose: cropping soft plant material. Not conifer needles, not tough cycad fronds, not the woody stems of horsetails. Only the tenderest shoots, the youngest fern leaves still curled in their fiddlehead stage, succulent and packed with water and nutrients. The calf eats hungrily, moving from plant to plant in a tiny radius, never straying far from the fallen tree fern that offers a retreat. With each mouthful, the digestive miracle begins. And it is a miracle. Inside the calf's gut, a fermentation chamber is already forming. A proto-stomach that will one day be vast enough to process hundreds of pounds of vegetation every day, but which for now is barely the size of a walnut. It is colonized by microbes passed from the eggshell, microbes that can break down cellulose into energy. Without them, the calf would starve on a full belly. With them, it begins to gain weight by the hour. The first night of the calf's life is a crash course in fear. The Jurassic forest after dark is not silent. It is a symphony of clicks, trills, bellows, and the heavy, rhythmic breathing of animals that hunt by starlight. The calf huddles beneath the fern log as footsteps approach, pause, then move on. Some are small, tiny mammals scurrying through the leaf litter, hunting insects. Some are larger, much larger. A ceratosaur, its nasal horn casting a crooked shadow, sniffs the air precisely where the calf had been feeding an hour earlier. The predator's tongue flicks out to taste the scent molecules, decoding the information with a precision that would shame any modern forensic lab. It knows the calf is nearby. It knows the calf is small. But the jungle is thick, and the effort of rooting through every fallen log is costly. After a long, terrible pause, the ceratosaur moves on. The calf does not understand that it has just survived its first encounter with death. Its brain merely registers the danger and floods its body with a chemical that will linger for days. Cortisol, the stress molecule that accelerates metabolism and redirects energy into growth. In the Jurassic, fear literally makes you bigger. Dawn brings more eating. The calf has discovered a patch of club mosses, their spore-bearing cones soft and easily digestible. It eats until its tiny belly is distended, then retreats to sleep. And while it sleeps, its body converts plant matter into bone at a rate that seems biologically impossible. 2 days after hatching, the calf weighs 3.5 pounds. By the end of its first week, it has doubled its hatchling weight. The growth is visible in the thickening of its limb bones, the lengthening of its neck, the beginning of a tail that will one day counterbalance a body weighing tens of tons. For now, the tail is a fragile, whip-like thing, used for little more than balance when the calf must run. And it must run, and run often, because the predators are learning. The calf is not the only hatchling that survived its first day. Scattered across this single river valley, perhaps 100 other Brachiosaurus eggs have hatched in the last 72 hours. From 30 eggs per nest, maybe 5 produced live young. The rest were lost to flooding, to fungal infections, to the sharp snouts of egg-eating theropods that haunted the nesting grounds like crows haunting a cornfield. The survivors are spread thin, each one navigating its own solitary childhood, burning through its own store of luck. And luck already is running out. On the 10th day, the calf encounters an Allosaurus. Not an adult, a juvenile, 4 feet tall at the hip, lean and fast and brimming with a hunter's curiosity. It spots the calf from 30 yards away, its forward-facing eyes locking on the moving shape among the ferns. The calf freezes. The Allosaurus cocks its head, processes the image, and the decision is instantaneous. Prey. The chase lasts 12 seconds. The calf bolts toward a dense thicket of horsetails, its legs pumping with a speed that seems impossible for something that was an embryo less than 2 weeks ago. The Allosaurus covers the distance in 3 strides, its jaws snapping shut on the spot where the calf's tail had been a fraction of a second earlier. The calf crashes into the horsetails and keeps going, tearing through the jointed stems, which slap against its flanks but provide no real barrier. What saves it is not the vegetation. What saves it is a collapsed riverbank, a sheer drop of 3 feet that the calf tumbles over, rolling in a tangle of limbs and dirt, landing in a shallow pool of muddy water at the bottom. The Allosaurus, unable to navigate the drop at speed, skids to a halt above, hissing in frustration. It will not follow. The fall is too steep, the risk of injury too high. The calf, bruised and shaking, pulls itself onto a sandbar and lies still, its small chest heaving. Another molecule is flooding its bloodstream now, one that will define its entire adolescence: adrenaline. In the world of the Brachiosaurus, every growth spurt is paid for with moments of pure terror. Weeks pass, the calf heals, the bruises fade, and the leg that was wrenched in the fall knits itself together with a speed that would astonish a modern veterinarian. There is no infection. The calf's immune system, inherited from a line of survivors, is robust beyond its size. It continues to eat, to hide, to grow. By the end of its first month, it weighs 15 pounds. It is still small enough to be carried off by a large pterosaur if one were so inclined. But it has grown too large for the smaller predators to consider it easy prey. The juvenile theropods that once chased it now give it a wider berth. The calf, in return, is learning caution. It has mapped a territory of roughly 200 square yards, a network of hiding places, feeding patches, and escape routes. It recognizes the alarm calls of the small ornithischians that share its understory, the high-pitched squeaks that mean big predator near. It has learned to read the silence, to notice when the insect chorus suddenly cuts out, to move toward cover before the danger materializes. It is, in a very real sense, becoming a resident of this ancient world, a citizen of the Morrison Formation. And the Morrison Formation is a kingdom of titans. Beyond the calf's tiny domain, the landscape is staggering in its scale. Rivers wider than the modern Mississippi wind through forests of conifers that stand 200 feet tall. Herds of camptosaurs, fleet-footed and nervous, traverse the open fern prairies. Stegosaurus, its plates flashing with blood-warmed color, grazes on low cycads, its thagomizer a deterrent to even the largest predators. Parasaurs with 40-foot wingspans ride the thermals overhead, their shadows sliding across the ground like dark, silent prophecies. And towering above it all, the adult sauropods. Not just Brachiosaurus, but Apatosaurus, Diplodocus, Camarasaurus, the true giants, their necks rising like living architecture, their footsteps registering on the landscape as seismic events. The calf has not yet seen an adult of its own species up close, but it has felt them. On calm days, when the wind is still, the ground trembles with a rhythm that the calf's body recognizes deep in its bones. It is the sound of its own future, walking. But the future is not guaranteed. Far from it. Most calves do not survive their first dry season. The rains that fed the ferns and filled the pools begin to falter. The lush greenery browns at the edges. The salad bowl that sustained the calf's first week shrinks, and competition for the remaining tender browse intensifies. The calf, now weighing nearly 30 pounds, must range farther to find food, and ranging farther means encountering more of the world's sharp edges. The dry season also concentrates the predators. As water holes shrink, the herbivores are drawn into tighter circles, and the carnivores follow. The calf's once private feeding grounds are now crisscrossed by the tracks of other young sauropods, each one a potential competitor, each one a potential lure for predators. The calf begins to cross paths with others of its kind. They ignore one another. There is no social bonding among these early-stage juveniles. Evolution has not yet wired them for herd behavior. That will come later, when the body is large enough to offer safety in numbers. For now, every calf is an island, and some islands are sinking. The calf witnesses its first death on a sweltering afternoon when the air is so thick, with humidity, that the forest seems to breathe. A young Ornitholestes, a small theropod covered in primitive feathers, has cornered another Brachiosaurus calf against a fallen tree. The victim is slightly smaller than our calf, weaker, perhaps sick. Its attempts to flee are sluggish, the predator's jaws close around its neck. The struggle is brief. The forest floor absorbs the blood with the same indifference it shows everything else. Our calf watches from beneath a fern, frozen. When the Ornitholestes drags the body away, the calf does not move for an hour. When it finally does move, it moves with a new understanding, encoded now not just in instinct, but in memory. Death is real, and it is always hungry. By the 6-month mark, the calf is a different animal. From a 2-pound hatchling, it has become a creature that weighs over 100 pounds. Its neck, once delicate, has begun to elongate. Its body is taking on the unmistakable silhouette of a sauropod. Though still miniaturized, a toy version of the monster it will become. It can now browse on vegetation up to 2 feet above the ground, giving it access to food that the smaller hatchlings cannot reach. The competition has eased, but the stakes have only risen. Because at 100 pounds, the calf has outgrown the smaller predators. It has not outgrown the large ones. And the large ones are starting to notice it. Allosaurus, the apex predator of the Morrison, is built to kill subadult sauropods. Its serrated teeth are designed to strip flesh from bone. Its claws can hook into a flank and hold on while the jaws do their work. And its brain, though small by modern standards, is more than sufficient to calculate the risk of attacking a 100-pound juvenile that is still far from being able to defend itself. The calf is in a lethal middle ground, too big to hide, too small to fight. Every day is now a high-stakes game of stealth and speed. But the most insidious threat is not external. It is something the calf carries within its own body, a flaw buried in the very architecture of its skeleton. The trait that defines Brachiosaurus, the towering neck, is also its greatest vulnerability during adolescence. To reach the canopy, the neck must grow at a phenomenal rate, faster than the forelimbs, faster than the torso, faster than the supporting musculature can keep up with. The cervical vertebrae are elongate, hollowed by air sacs, marvels of evolutionary engineering that allow maximum length with minimal weight, but they are also fragile, especially in juveniles. And the muscles that hold them erect, the massive ligament system that runs along the spine like a suspension bridge cable, must grow in precise synchronization with the bones. If the bones outpace the muscles, the neck becomes ungovernable. The first sign of trouble appears in the calf's gait. Somewhere around month 7, the calf begins to carry its head lower, where, once it could raise its neck to browse 2 feet off the ground, it now struggles to reach 18 inches. The muscles along the back of its neck are visibly strained, cords of tissue pulled taut as they fight to support a load they were never designed to bear. The calf begins to tire more quickly. Its feeding time increases because it must rest between mouthfuls. And because it is spending more time with its head down, it is less aware of its surroundings. The predators notice. On 3 separate occasions, the calf is nearly taken by an Allosaurus that crept within striking distance before the calf sensed the danger. Each escape costs precious energy and leaves the calf more weakened. The condition worsens as the weeks drag on. The neck continues to grow. The muscles do not. The cervical vertebrae, now 18 inches long, are held together by tissue that is inflamed and micro-torn. The calf begins to lose weight. The food it can reach at ground level is less nutritious than the higher browse it can no longer access. A vicious circle tightens. Less nutrition means less energy to build the very muscles that would allow the neck to lift. The calf, once a beacon of frantic life, becomes listless. Its ribs begin to show beneath the skin. The gleam of its eyes dims. One morning, after a night spent lying beneath a cycad, the calf tries to rise and fails. It manages to get its hind legs under it, but when it attempts to lift its head, the neck simply does not obey. The muscles have given out completely. The calf's head lolls to one side, its muzzle dragging in the dirt. It tries again, straining with every fiber, and the effort produces nothing but a faint, involuntary tremor in the neck. The calf is now unable to raise its head above the level of its shoulders. It cannot graze, it cannot drink from any source that isn't directly beneath its mouth. It cannot watch for predators. It is helpless in a world that does not tolerate helplessness. The calf settles back onto its stomach, and for the first time in its short life, there is no fight left. The forest continues its indifferent chorus. A dragonfly lands on the calf's flank, tastes the salt of its skin, and departs. The calf's breathing slows. The sun climbs higher, and somewhere in the distance, a vibration begins, a deep rhythmic thud that grows steadily louder. The calf is too weak to react. The sound resolves into footsteps, incredibly heavy, each impact a detonation. Whatever is approaching, it is huge, and it is coming closer. The sound is not a single set of footsteps. It is a sequence of impacts so heavy that the ground shudders in anticipation between each one, as if the earth itself is holding its breath. The calf, sprawled on its belly with its head lolled uselessly in the dirt, can do nothing but register the approach through every nerve ending that still functions. The vibration climbs through its ribcage, through its sternum, into the very fluid of its inner ear. The message is primal and undeniable. Something titanic is coming, and it is coming directly toward this patch of forest. The ferns shiver. A young conifer, only 15 feet tall but thick-trunked, sways as the ground beneath its roots deforms. A cloud of insects lifts from the understory, a rising murmur of wingbeats fleeing the disturbance. And then, through a gap in the canopy, a shape blocks out the sun. A pillar of living flesh, textured like ancient leather, descends from the sky, except it is not descending from the sky. It is attached to a body that stands higher than any building the modern world will construct for 10,000 years. The foot, when it lands, sinks 6 inches into the soft soil, sending concentric ripples through the leaf litter. The calf is flung half an inch upward by the impact. The adult Brachiosaurus has arrived. It is a female, perhaps 70 years old, her hide scarred with the history of 1,000 skirmishes and one long lifetime of absolute dominance. Her neck rises 70 feet into the canopy, the curve of it a monument to evolutionary engineering. She is not looking down. Her attention is fixed on the high branches, on the tender ginkgo leaves that she strips with the slow, rhythmic pull of her peg-like teeth. She does not see the calf, a crumpled speck in the shadow of her own ankle. The difference in scale is so vast that the calf is less significant to her than a pebble underfoot. But her sheer presence is about to change everything for the tiny life trembling in her. Shadow. First, the ground vibration that announces her arrival travels ahead of her like a seismic herald. It reaches the ears of a Torvosaurus, a 40-foot, 3-ton predator that had been slinking through the ferns at the edge of the calf's clearing. Torvosaurus is the nightmare that even Allosaurus avoids. Its teeth are the size of steak knives. Its arms are tipped with talons that can disembowel with a single swipe. It had spotted the fallen calf 20 minutes earlier and was approaching with the patience of a surgeon, waiting for the precise moment when the calf's last reserves of adrenaline would be exhausted, when the heart would slow and the eyes would finally close. Now it freezes. The ground beneath its own feet is trembling with a signature that its brain, honed by evolution to sort threats instantaneously, recognizes as non-predatory but utterly unassailable. A full-grown Brachiosaurus is not a threat it can fight. It is a threat it can only avoid. The Torvosaurus hisses, a low, frustrated exhalation, and melts back into the shadows, its hunt abandoned. The calf will never know that it was minutes from death. Second, The adult's passage alters the immediate environment in ways that are catastrophic for the forest, but salvational for the calf. Her hindfoot, as wide as a bathtub, crushes a fallen log that had dammed a tiny seep of groundwater. The log, already rotten, explodes into pulp. The seep, suddenly freed, becomes a trickle. The trickle carves a channel through the disturbed soil, and within seconds, a small pool begins to form less than 3 feet from the calf's muzzle. The water is brown with sediment, but it is water. The calf, whose body has been cycling the last drops of hydration from its tissues, whose kidneys are beginning to slow, whose blood is thickening toward a lethal sludge, smells the moisture. The instinct to drink overrides every other signal of exhaustion. With a monumental effort, it drags its head 3 inches forward and lets its lips touch the edge of the new pool. It drinks. The water is the first thing that has gone right in weeks. And then, the third and most incomprehensible intervention. The adult Brachiosaurus, having stripped the branch she was targeting, shifts her weight. Her front foot, the same one that could crush the calf into an unrecognizable stain, lifts and descends again and lands, not on the calf, but directly alongside it, so close that the displaced air buffets the calf's flank and a clod of dirt strikes its ribs. The adult has not looked down. She has simply placed her foot in the spot that her brain calculated as the next, stable step on her path to the river. But the effect is immediate and transformative. The impact drives the calf's body upward, and in that involuntary lift, something unlocks. The neck, which has been frozen in a paralyzed droop, spasms. The calf's head jerks upward just a few inches before falling back. But for that fraction of a second, the neck muscles fired. The nerve signal that had been failing for days has been jolted back into conductivity. The calf, still lying prone, gulps more water, and its body registers a new sensation. Not strength, not yet, but the ghost of strength, the possibility. The adult Brachiosaurus moves on, her tail sweeping a curve through the ferns, and within minutes she is gone, her footfalls fading into the ambient tremors of the landscape. The calf is alone again, but it is not the same calf that had collapsed an hour earlier. It has drunk, it has felt its neck move, and now, with water in its belly and the scent of the torn soil in its nostrils, it begins to do what Brachiosaurus calves are engineered to do. Even when everything else is failing, it tries again. The struggle is not elegant. It is a flailing, spastic, uncoordinated battle against gravity and anatomy. The forelimbs push against the mud. The hind limbs scramble, slipping, finding purchase, slipping again. The neck, still perilously unsupported, swings like a poorly balanced crane. But inch by inch, the calf rises. Its head clears the ground by a foot, then by a foot and a half. The muscles along the cervical spine are screaming, micro tears spreading through tissue that has been starved of glucose. But the calf holds the position. It sways, locks its knees, and stands. It is the most important stand of its life. The next 3 days are a vigil of persistence. The calf cannot yet lift its head high enough to browse the club mosses it had relied on before the crisis. But the pool that the adult's step liberated has become a micro-ecosystem. Tender water plants, their roots newly submerged, send up fresh shoots. The calf grazes on these, its muzzle barely above the water's surface. The plants are soft, digestible, and rich in the minerals that its body has been starving for. Slowly, one mouthful at a time, the calf begins to rebuild. The muscle fibers that had torn and inflamed begin, at last, to knit. Growth, which had stalled entirely for nearly 2 weeks, restarts. The neck, which had been the agent of near death, becomes the focus of a miracle. And here is where the science almost sounds like fiction. Inside the cervical vertebrae of a juvenile sauropod, something extraordinary occurs. The bones are not yet fully ossified. They contain a lattice of cartilage that is capable of rapid remodeling under stress. When the neck muscles fail, the brain does something remarkably adaptive. It triggers a local release of growth factors, proteins that are normally distributed throughout the entire skeleton, but are now concentrated in the regions under the most mechanical load. The inflammation that had been destroying the calf's muscle tissue now becomes a signal that says, reinforce here, strengthen here, or die over the next month. The calf's neck muscles will grow thicker than any other muscle group in its body. The ligament system, the nuchal ligament that runs from the back of the skull to the shoulders, will double in cross-section. The calf's head will never droop again. But the world does not pause for recovery, and even as the calf heals, the landscape continues to reshuffle its dangers. The dry season has broken. The first clouds of the monsoon gather on the horizon, bruised, dark, and heavy, with the promise of transformation. When the rains come, they come not as gentle showers but as walls of water that turn the river from a meandering giant into a raging, debris-choked flood. The pool that saved the calf's life will vanish under 6 feet of churning brown water. In the space of a single afternoon, the calf will survive that flood, but not from luck. It will survive because it has already learned to read the land, to sense the changing pressure in the air, to move toward higher ground before the water arrives. It is still a child, but it is a child that has now faced the worst trial of its species, and past months accumulate. The calf grows. By the end of its first year, it weighs 250 pounds. It is still, in the grand scheme of the Jurassic, a snack-sized creature, but it is now too large for the flutter of small theropods and too fast for the giant crocodilians that patrol the riverbanks. Its neck, once a liability, is now its primary tool. It can browse up to 5 feet off the ground, a height that puts it above the competition of the ornithischians and the smaller sauropodomorphs that share its territory. It has developed a pattern. Feed at dawn, shelter during the heat of midday, feed again in the late afternoon, and move under cover of darkness to new feeding grounds. It sleeps lightly, always with one ear tuned to the frequency of danger. It has not forgotten the Torvosaurus it never saw, but it has survived one full circuit of the seasons, and that is more than 85% of its siblings can claim. Year 2 is a time of consolidation. The calf, now a juvenile sufficiently distinct from its hatchling self to be called a subadult, has begun to shed the solitary habits of infancy. This is not a conscious choice. It is a shift in brain chemistry that emerges as the body reaches a certain size. The drive to disperse, to hide, to avoid all contact, begins to attenuate. In its place, a new drive stirs, the drive to seek out others of its kind. It is not herd instinct as we understand it. It is more primitive, a recognition that bodies close together mean more eyes to spot a predator, more nostrils to scent the wind, more muscle to deter an attacker. It is safety in numbers, written deep in the sauropod genome. The first encounter is tentative. The calf, now moving through a stretch of open fern prairie, detects a shape in the distance that shares its silhouette. Another Brachiosaurus, slightly larger, perhaps a year older. The two juveniles approach one another slowly, stopping every few strides to reassess. There is no greeting, no vocalization that we can interpret as a call. But there is a shared moment of stillness, a mutual sizing up. Then, without ceremony, the older juvenile turns and resumes grazing, and the calf falls in behind it. A bond has formed, not through affection, but through a calculation of survival that neither brain can articulate. By the end of the day, a third juvenile has joined them. By the end of the week, the calf is part of a loose aggregation of 7. They will stay together for the next 3 years. The subadult herd is a survival machine. In a group, the calves are safer from the predators that still hunt them. Allosaurus still takes subadults, But the risk calculation shifts when there are 6 pairs of eyes scanning the trees and 6 tails ready to lash. The tail of a 2-year-old Brachiosaurus is not a whip like a Diplodocus, but it is strong enough to send a small theropod tumbling, and the sound of 7 subadults stampeding is enough to make even a large Allosaurus reconsider. The herd also provides a social education. The juveniles learn from each other which fern patches are richest, which river crossings are safest, how to recognize the alarm calls of the stegosaurs and the pterosaurs that share their world. The calf, once a solitary survivor, is now a member of a society, and this society is about to be tested in the late dry season of the calf's 5th year, when it now weighs nearly 2 tons and stands 12 feet at the shoulder. The Morrison Formation experience is a phenomenon that is rare but catastrophic, a superstorm, a convergence of tropical moisture and atmospheric pressure that produces a flood event so extreme that the river valleys are transformed into a continuous lake. The water rises not in hours, but in days, inexorable, muddy, filled with the carcasses of animals that could not reach high ground in time. The sub-adult herd, now numbering 12 individuals, is caught in the middle of a migration toward the uplands. The youngest members, still less than a ton, struggle against the current. The older juveniles form a protective line, their bodies acting as a breakwater, their necks held high above the churning water. The calf, now a mid-ranking member of the herd, is strong enough to stand against the flow, but the water is cold, and the cold saps muscle efficiency. Hypothermia is a killer that no amount of size can deter. The herd loses 3 of its youngest members that night, swept away by a surge of debris-laden water. The calf, huddled with the survivors on an isolated rise of land that may be underwater by morning, watches the brown water churn past and learns a new truth about the world. It is not only predators that kill. The environment itself is a predator, patient and indiscriminate. But the herd survives. At dawn, the waters begin to recede. The sun emerges, and the survivors step onto new ground that has been scoured clean of vegetation, but also cleansed of predators. They are in a different part of the valley now, a place they have never been. And it is here that the calf will encounter something that changes the trajectory of its life for a second time. What the calf encounters is a herd of adults, not subadults like itself, not the loose, shifting aggregations of juveniles that drift through the fern prairies, but a true breeding herd, 30 or 40 individuals of immense size, their necks a forest canopy made flesh. The subadult herd has been driven by the flood into the heart of a gathering that it would normally avoid for several more years. The adults are not hostile. They are simply indifferent, but their presence exerts a gravity that the subadults cannot resist. Slowly, over the course of weeks, the younger herd integrates itself into the fringes of the larger group. The calf, now a juvenile of 5 years and 2.5 tons, is no longer a loner or a member of a teenage band. It is now part of a multi-generational society, and it is here, among the titans, that the final phase of its growth will occur. But joining the adult herd does not mean safety. It means new dangers, new hierarchies, and a new kind of vulnerability, because the adults are not the only ones who have noticed the flood survivors. The storm has displaced predators as well as prey, and the largest predators in the Morrison ecosystem are pack hunters. Allosaurus, in particular, is known to hunt in coordinated groups when the prey is large enough, and a gathering of adult sauropods with subadult attachments is a concentration of biomass that no apex predator can ignore. The calf has survived the infancy gauntlet and the superstorm. Now it must survive something worse, a coordinated attack by a pack of 5 Allosaurus, each one 12 feet tall, each one weighing 2.5 tons, their brains wired for tactical cooperation, and they are already circling the herd, testing for weakness, waiting for darkness to fall. The pack does not attack immediately. That is not how Allosaurus operates. The 5 hunters are not a random assortment of individuals thrown together by chance. Paleontological evidence from the Cleveland Lloyd Quarry, where the bones of over 46 Allosaurus individuals have been found in a single deposit, suggests that these predators formed complex social groups, perhaps not permanent packs like modern wolves, but fluid coalitions that came together when the opportunity demanded cooperation. And what the flood has created is an opportunity of a scale that even these predators rarely encounter. A mass gathering of sauropods, young and old, their normal defensive formations disrupted by the scramble to high ground. The Allosaurus pack begins its work at dusk. They are invisible in the fading light, their mottled hides blending perfectly with the shadows of the conifer trunks. They communicate not with roars but with subtle postures, head tilts and the silent flick of a tail. One of them, the largest female, takes the lead position, downwind of the herd. 2 others split off to the east, moving with the liquid patience of creatures that have no need to rush. The remaining 2 circle wide to the west, their path taking them through a gully that masks their scent. Within an hour, the herd of Brachiosaurus is surrounded on 3 sides. The adults sense the shift. Their heads, which had been browsing the high canopy, lower. Their nostrils flare. The subadults, including our calf, pick up the tension and begin to draw closer to the adults, their instinctive trust in size momentarily overriding their instinct to flee. It is a mistake they will not fully understand until it is too late. The attack, when it comes, is not a frontal assault. The lead Allosaurus does not charge the nearest adult. Instead, she waits until a young male, an adolescent only slightly older than our calf, drifts a few yards too far from the protective shadow of the largest female. The moment the gap opens, the leader makes a feint, dashing toward the herd with a burst of speed that covers 40 yards in under 4 seconds. The adults react, turning their massive bodies to face the threat, their forelimbs lifting. But the feint is exactly that, a distraction. While every eye is on the charging leader, the 2 flanking Allosaurus strike from the east. Their target is not the adolescent male. It is a juvenile, even younger, perhaps 3 years old, barely a ton, separated from the main body of the herd by a fallen log it could not climb. The first Allosaurus hits the juvenile at full speed, its jaws clamping onto the base of its tail. The second strikes the neck, its serrated teeth slicing through the nuchal ligament that our calf's body had worked so desperately to strengthen a few years earlier. The juvenile goes down with a crash that shakes the ferns. The adults bellow, but the attack is over before any countermove can be made. The 2 flanking predators drag the struggling juvenile backward into the shadows, and the leader, having completed the feint, melts back into the trees. The pack has their meal. The herd is down 1 more member. The slaughter, precise and economical, has taken less than 90 seconds. Our calf does not sleep that night. It stands rigid among the subadults, its entire nervous system flooded with the same chemical cocktail that saved its life as a hatchling. But now the cocktail is processed by a larger brain, a brain that has learned to interpret fear not just as a reflex but as information. The Allosaurus pack will return. The herd is a magnet, and the predators know that their strategy works. The calf begins to neurologically rewire itself in real time, its threat detection systems upgrading to handle a threat level it has never before encountered. And the most critical upgrade involves recognizing the tactics of the pack. The feint, the flank, the exploitation of the herd's instinct to mass. This knowledge, once internalized, will become the foundation of every defensive choice the calf makes for the rest of its life. The pack returns the next night, and the next, and the night after that. They do not attack every time. Sometimes they simply test the perimeter, watching to see which members of the herd are consistently at the edges, which are slow to respond to alarms, which have developed injuries from the long trek through the floodwaters. They are compiling a database. The calf, for its part, has begun to reposition itself within the herd, always staying close to the largest adults, always keeping its head up and scanning, always remembering the eastern approach vector that the flankers favored. It cannot fight an Allosaurus, but it can make itself a less attractive target, and it does. On the fifth night, the pack attempts a variation on the feint tactic. The leader charges from the north, but this time, the flankers are not positioned to the east. They are positioned to the south, directly in the path that the subadults have been using to retreat when the adults wheel. To face a threat, the goal is to drive a wedge between the young and the old, to isolate the most vulnerable before the adults can pivot. The leader begins her charge. The subadults, including our calf, instinctively begin to move south, and then the calf stops. It has recognized the pattern. The southern approach runs directly between two large conifers, a natural bottleneck that the calf has noted every single night since the first attack. If there were flankers positioned there, they would be invisible until the subadults were already in the kill zone. The calf stops, plants its feet, and refuses to move south. It bellows, a reedy, adolescent bellow, nothing like the deep seismic calls of the adults, but enough to draw attention. The other subadults, confused by the sudden halt, mill in place. And in that moment of stalled retreat, the two flankers break cover, their ambush revealed. They had been lying in the bottleneck, precisely where the calf feared. The adults, still wheeling from the leader's feint, now see the flankers in the open. Two adults lower their heads and swing their necks in a broad, sweeping arc, a gesture that is not aggressive but is undeniably a warning. The flankers, outnumbered and exposed, back away. The ambush has failed. The pack will not eat tonight. It is a small victory, measured against the losses the herd has already sustained. But for the calf, it is a turning point. The act of recognizing the pattern, of overriding the herd's collective instinct, of making a decision that altered the outcome of a predation event, this is the emergence of true situational intelligence. The calf is no longer merely a passenger in its own survival. It is an active participant, a strategist working with tools that evolution has spent 100 million years refining. And the herd notices, not in any conscious, narrative way, but in the subtle adjustment of proximity that follows the event. The calf finds itself, over the following days, positioned more often near the center of the subadult cluster than at its edges. The herd is not capable of gratitude, but it is capable of a statistical recognition. This one sees danger before danger arrives. This one is worth following. The dry season grinds on. The herd continues its slow migration toward the northern uplands, where the conifer forests remain green and the rivers still run. The calf grows. By the end of its 6th year, it weighs 4 tons. Its neck has reached a length of 15 feet, and the muscles that once failed, so catastrophically, now bulge with dense fibers. The result of the calcium-rich diet and the constant, mechanical loading of browsing. The neck is no longer a vulnerability. It is a weapon, a tool, and a flag of identity. In the adult herd, neck posture communicates everything. Dominance, receptivity, alertness, illness. The calf is still too young to participate in the full language of neck display, but it watches the adults and learns. Year 7 is the year of the great drought. The monsoon fails to arrive. The seasonal rains that should have begun in the spring simply do not come. The river that the herd has been following shrinks to a chain of stagnant pools, each one smaller and more crowded than the last. The ferns wither. The cycads drop their fronds. The easy browse that sustained the subadults through their growth spurts vanishes, and the herd is forced to spend more and more time stripping the tough, fibrous leaves of the conifers. For the adults, this is manageable. Their fermentation chambers are vast, capable of extracting energy from even the most recalcitrant plant matter. For the subadults, whose digestive systems are still developing, the nutritional deficit accumulates. The calf begins to lose weight for the first time since its neck crisis years ago. The drought is not selective. It pressures every member of the herd, but the pressure falls heaviest on the young. Two of the remaining subadults, both slower growing than the calf, succumb to a combination of malnutrition and parasite load. Their guts, already strained by the poor quality browse, become breeding grounds for nematodes whose eggs had lain dormant in the mud of the shrinking waterholes. The calf watches them weaken, watches the Allosaurus pack, still shadowing the herd from a distance, close in and finish them. It is a brutal reminder that the calculus of survival never stops. Growth must continue, or death will catch up. But the calf has a secret advantage now, one that has been building invisibly throughout its life. Its microbiome, the community of gut microbes that colonized its digestive tract as a hatchling, has been diversifying. With every new food source the calf has encountered, the flood plants, the upland conifers, the tough ferns of the dry season, each has contributed a new strain of cellulose-digesting bacteria to the calf's internal ecosystem. By year 7, the calf's gut is home to a microbial consortium so efficient that it can extract usable energy from plant matter that would pass undigested through a less experienced animal. This is not a conscious adaptation. It is a passive acquisition, a slow accumulation of biodiversity that has turned the calf from a consumer of the Jurassic flora into a master of it. And as the drought deepens, that mastery becomes the difference between life and death. The herd's migration reaches the northern uplands. The conifer forests here are still productive, their deep roots tapping groundwater that does not depend on seasonal rain. The calf, released from the nutritional bottleneck, begins to regain the lost weight with startling speed. By the end of year 7, it weighs 5 tons. By year 8, 7 tons. Its growth curve, which had threatened to flatline, has returned to the steep ascent that defines successful Brachiosaurus development. It is now among the largest of the subadults in the herd, and its size is beginning to afford it a new kind of immunity. The Allosaurus pack still shadows the herd, but they no longer test the calf directly. At 7 tons, it is simply too large for them to risk a direct engagement. The calf has passed the threshold where predation is the primary threat. From this point forward, the dangers are different. They are internal. Because now the calf is entering the final and most biomechanically extreme phase of its growth. The transition from subadult to adult Brachiosaurus is not a gradual enlargement. It is a transformation that reshapes every bone, every joint, every muscle attachment point in the body. The forelimbs, which have been growing steadily, are about to enter a growth spurt that will make them longer than the hind limbs, a trait unique to Brachiosaurus among the sauropods, giving the adult its characteristic giraffe-like posture. The neck will add another 10 feet of length. The torso will widen to accommodate a digestive system capable of processing 300 pounds of vegetation per day. And all of these changes must happen simultaneously, coordinated by a hormonal cascade that is unforgiving of any error. The process is brutal. The calf experiences growing pains that would be agonizing to a human, but its nervous system processes pain differently. It does not suffer in the psychological sense. Instead, the discomfort manifests as restlessness, a constant urge to move, to flex, to load the growing bones with mechanical stress so that they will remodel correctly. The calf spends hours each day walking, its pace slow but relentless, its neck swaying in broad patterns that distribute the load of the cervical column across every attachment point. It is engaging in physical therapy without knowing it, obeying an instinct that has been programmed by evolution to counteract the risks of rapid growth. The alternative, lying still, conserving energy, would be fatal. Bones that grow without mechanical loading become weak, brittle, prone to the catastrophic fractures that killed so many of the calf's siblings in their early years. The calf must move, and so it moves. The process also reshapes the calf's social standing. As it grows larger, it begins to seek out the presence of the dominant adults with greater intensity. Not for protection now, but for education. The adult herd, particularly the matriarchs, possesses a knowledge base that is not genetic. It is cultural, the routes of the migrations, the timing of the breeding season, the locations of mineral-rich soils where calcium and other essential elements can be supplemented by geophagy, the deliberate eating of earth. These are not instincts. They are learned behaviors, transmitted down the generations through observation and imitation. The calf, now large enough to move safely among the oldest members of the herd, begins to absorb this knowledge with an intensity that will shape its behavior for the rest of its life. Year 10. The calf weighs 15 tons. It is no longer a calf in any meaningful sense. It is a young adult, still growing, still years from sexual maturity, but already a presence that shapes the landscape around it. Its neck, now 25 feet long, can reach the middle branches of the conifers. Its footprint, when it steps, leaves a depression 6 inches deep, and the ground compacts beneath its weight into a signature that will one day be fossilized and studied by a species that does not yet exist. It has become one of the architects of the Morrison Formation, a co-creator of the ecosystem that has defined its entire existence. But even at this size, the calf, no, the young adult, is not safe from the deadliest predator it has ever faced. Not Allosaurus, not Torvosaurus, not flood or drought. The deadliest predator is time itself, and time, for a Brachiosaurus, has a very specific weapon, the growth plateau. Every sauropod that survives to subadulthood faces a biological cliff. The growth rate that sustained it through infancy, that doubled its mass every 100 days, that powered it past the predators and the floods and the droughts, that growth rate cannot continue indefinitely. At some point, the hormonal cascade that drives osteogenesis must decelerate, and when it does, the animal enters a perilous zone. If the deceleration is too abrupt, the body will be left underpowered relative to its own mass, a giant that cannot carry its own weight. The joints will fail. The bones will develop stress fractures. The heart, still sized for a smaller animal, will struggle to pump blood up a neck that is now 30 feet long. The transition to adult growth rate, when it comes, must be exquisitely timed. And the timing is different for every individual. For some, it happens at 50 tons, for others at 40. For a few, tragically, it never happens at all. Their bodies simply keep pouring energy into skeletal growth until the bones become so dense that they lose the elastic flexibility that living tissue requires. Those individuals die of their own success, their skeletons unable to absorb the impact of every step. The young adult Brachiosaurus, now 12 years old and 30 tons, is approaching this transition point without any way of knowing where its own threshold lies. Its body will either achieve the metabolic handshake that shifts energy from skeletal growth to maintenance and reproduction, or it will break. The next 2 years will decide whether the calf's decade of survival has been a prelude to centuries of life or an elaborate prelude to a sudden, quiet collapse, and the first sign of which path it will take is already appearing, written in the microscopic ridges of its bones. The microscopic ridges in the bones of a Brachiosaurus are called lines of arrested growth, or LAJs. In most animals, they are the skeletal equivalent of tree rings, marking seasons when growth slowed or stopped entirely, winters, dry spells, periods of starvation. In the long bones of a healthy, rapidly growing juvenile sauropod, Louises should be sparse, widely spaced, a record of uninterrupted acceleration. But in the long bones of our young adult, something different has begun to appear. the paleontologists who would one day slice these femurs into translucent wafers and peer at them through microscopes would count not the expected handful of growth lines, but a sudden, dense clustering. Between year 12 and year 14, the L-eggs tighten into a record of profound metabolic stress. The animal whose skeleton now lies shelved in a museum drawer was, at this exact moment in its life, on the razor's edge. The stress is invisible from the outside. The young adult Brachiosaurus does not limp. It does not favor one side. Its posture, to any observer from the forest floor, is indistinguishable from that of the other subadults in the herd. But deep inside its long bones, inside the marrow cavities of its femurs and its humeri, a quiet crisis is unfolding. The osteoblasts, the cells responsible for laying down new bone, are receiving conflicting signals. One hormonal pathway, driven by the thyroid, is screaming grow. Another pathway, driven by the parathyroid, is screaming consolidate. The two signals are supposed to alternate and in a carefully timed sequence that gradually downshifts the growth engine. In our young adult, they are colliding simultaneously, and the result is a patchwork of bone deposition so disorganized that any engineer would recognize it as structural failure in progress. The bones are not yet breaking. They are still immensely strong relative to any force applied to them in daily life. But the microarchitecture of the cortical bone, the dense outer layer that bears the creature's weight, is developing what material scientists call anisotropy, directionally dependent weakness. The bone is strong when loaded along one axis, the axis the body has been reinforcing since infanthood, but dangerously brittle when loaded along another. A twist, a torque, a sudden lateral load that the leg has never had to absorb before. And the young adult Brachiosaurus, now weighing 35 tons and still growing, is about to encounter exactly that kind of load. It happens during the migration north, on a stretch of terrain that the herd has traversed 100 times before. The path follows an ancient game trail that contours along the side of a low hill, crossing a slope of loose shales and exposed sandstone. The young adult is moving in the middle of the column, its neck swaying in its habitual rhythm. When the ground beneath its right forefoot gives way, the shales, weakened by a season of drought followed by a sudden thunderstorm, have delaminated. A slab of rock, the size of a dining table, slides 6 inches downhill beneath the animal's weight. The forefoot twists outward. The leg, designed to absorb impact in a straight line, is suddenly loaded laterally at 35 tons of pressure. The stress concentrates in the midshaft of the femur, precisely where the microarchitectural disorganization is most severe. And the bone, for the first time in the young adult's life, cracks. The sound is not a snap. It is a deep, wet, percussive thud that travels through the animal's skeleton and registers in its brain as a wash of white noise louder than any predator roar it has ever heard. The young adult staggers. Its foreleg, unable to bear weight, buckles, and the entire creature lurches downhill, its massive body sliding over the broken shales in an avalanche of dust and small rocks. It does not go over the hill entirely. The slope is shallow, and the body arrests its slide after 20 feet, crashing into the trunk of a young conifer that splinters under the impact. The young adult lies on its side, its neck extended uphill, its breathing ragged, its right foreleg held at an angle that is unmistakably wrong. The herd stops. The adults turn, their massive heads swiveling, to look at the fallen member of their group. There is a long, terrible silence, broken only by the hiss of the breeze through the conifer needles and the labored breathing of the injured animal. Then the matriarch, the oldest female, approaches. Her footsteps are slow, deliberate, each footfall pressing deep into the slope as she navigates the unstable ground. She reaches the young adult and lowers her head. her immense neck descending through 40 feet of air until her nostrils are inches from the fallen animal's flank. She exhales. The young adult exhales in return. Some exchange, beyond our interpretation, passes between them, scent, sound, the simple presence of another living titan. Then the matriarch turns, and without any visible signal, the herd begins to move again. They do not abandon the young adult. They simply cannot wait. The migration must continue. The calf that survived the egg, the drought, the superstorm, the Allosaurus pack, the neck muscle failure. The calf that has been fighting to live since the instant its shell cracked is now alone, broken, lying on a hillside, its entire future compressed into a single, excruciating question. Can a 35-ton sauropod heal a fractured femur? In the fossil record, the answer is written in the bones of the survivors, and those bones are surprisingly common. Somewhere between 5 and 10% of all adult sauropod femurs found in the Morrison Formation show evidence of healed fractures, not the jagged, unhealed breaks that indicate a death in the wild, but smooth, remodeled calluses, thick ridges of new bone that formed over months or years of recovery. Sauropods, despite their mass, despite the impossible physics of their anatomy, could survive bone fractures, and the mechanism by which they survived is, in its own way, as astonishing as their growth. The healing process begins almost immediately. When the femur cracks, the blood vessels that permeate the bone are torn, flooding the fracture site with a hematoma, a clot of blood that seals the wound and provides the initial scaffolding for repair. Within days, this clot is infiltrated by fibroblasts and chondroblasts, cells that lay down collagen and cartilage respectively. The cartilage forms a soft callus, a provisional bridge across the fracture that is strong enough to stabilize the bone ends, but flexible enough to be remodeled as healing progresses. In a human, this cartilaginous callus would eventually be replaced by hard bone through a process that takes months. But in a Brachiosaurus, the process is accelerated by a metabolic rate that, despite the animal's immense size, is still tuned for growth. The thyroid hormones that were causing the conflicting signals in the bone before the fracture now receive a clear instruction: heal, and they respond with a ferocity that is nothing short of biological fury. The young adult does not try to stand. It cannot. The broken leg will not support weight, and the instinct to rise has been overridden by a deeper, more ancient instinct: stillness, immobility, the preservation of the structural alignment of the bone fragments while the first stages of repair take hold. The animal lies on the slope, its breathing slowing, its heart rate dropping, its entire metabolic economy shifting from growth and locomotion to cellular repair. It does not eat, it does not drink. It has fat reserves, accumulated during the good years, that can sustain it for weeks. And it has one more resource that no human hospital could ever provide: the body temperature of a creature that weighs 35 tons. In a smaller animal, the metabolic cost of healing a major long bone would be so high that starvation or infection would almost certainly kill before the bone could knit. But sauropods were gigantotherms. Their immense mass retained heat so effectively that their body temperature remained nearly constant, day and night, season after season. That stable, warm internal environment was the perfect incubator for bone healing. The cells repairing the femur were operating in conditions that were, from a biochemical standpoint, ideal. Days pass. The herd has disappeared over the northern horizon, their dust trail the last visible sign of their passage. The young adult lies alone, the sun crossing overhead each day, the nights cold but never cold enough to threaten hypothermia. Insects crawl over its hide. A small pterosaur lands on its flank, pecks at a patch of dried skin, and departs. The scavengers have not yet arrived. The animal is still alive, and its scent still carries the markers of life that the great predators can read. But they are watching. The Allosaurus pack, or another pack like it, will eventually notice the prone, motionless form on the hillside. The question is whether the leg can heal enough, fast enough, to allow the young adult to stand and defend itself before the hunters close in. Week 2. The cartilaginous callus in the femur is now stiff enough that the bone fragments no longer grind against each other when the animal shifts its weight. This is a milestone. Grinding fragments cause continued bleeding, inflammation, and prevent the formation of the bony callus that will eventually replace the cartilage. With the ends stabilized, the process of ossification can begin. Osteoblasts, the bone-building cells, migrate into the fracture site and start depositing a matrix of calcium phosphate, the same mineral that gives bone its hardness. The matrix is laid down in a disorganized, chaotic pattern at first, a woven bone that is weaker than the original laminar bone, but stronger than cartilage. Over the course of weeks, this woven bone will be remodeled by osteoclasts, cells that dissolve bone, and replaced with properly oriented lamellar bone that can bear weight safely. The young adult's body is building a biological cast, internal and invisible, stronger and lighter than anything a surgeon could implant. But the cast cannot fully form while the animal lies in the open. The ground is too uneven. The leg is angled awkwardly, the bone fragments not perfectly aligned, and the healing callus is developing a slight angulation that will, if not corrected, leave the animal with a permanent limp. In a smaller creature, this might be fatal. In a sauropod, the body has a backup plan. The process of bone remodeling is not limited to healing fractures. It is a continuous, lifelong process that reshapes bones in response to the loads placed upon them. This is Wolff's Law, a principle of biomechanics that applies to all vertebrates, but which operates on an almost unbelievable scale in sauropods. Once the young adult can stand and walk again, the misaligned bone will gradually be reshaped by the mechanical forces of locomotion. The angulation will smooth out. The weak spot will be reinforced. Within a year, the fracture site will be stronger than the surrounding bone, a permanent callus that can be read by paleontologists 150 million years later as a scar of survival. Week 3. The young adult, for the first time since the fall, attempts to rise. It is not a full attempt. The animal shifts its weight onto its left foreleg, its intact hind legs, and lifts its chest a few inches off the ground. The broken leg remains folded, the hoof not touching the earth. The effort is brief, exhausting, but it is a signal. The brain is testing the body, probing the limits of the injury, preparing for the moment when standing becomes possible. The moment is not yet here, but it is close, and then the scavengers arrive. They are not Brachiosaurus, not Torvosaurus. They are smaller, more patient, more insidious. A pack of 6 ornitholestes, the feathered theropods whose smaller size belies their danger. They are not hunters of healthy adults. They are specialists in the sick, the wounded, the dying. They have been following the scent of blood and stress hormones for days, and now they circle the young adult at a safe distance, their heads bobbing, their eyes fixed on the prone giant. They do not know that the giant is still alive, still capable of healing, still burning with the will to survive that has defined its entire existence. They only know that it is still, and that the still things in the forest are usually meat. The first ornitholestes darts forward, nips at the young adult's tail, and retreats. It is a test. The young adult does not react beyond a twitch of the tail tip. A second predator approaches from the front, aiming for the soft tissue of the nostrils, a vulnerable point that can be exploited if the prey is too weak to defend itself. The young adult's eye, large and dark, tracks the approaching predator. The brain, flooded now with a new wave of adrenaline, makes a calculation. The broken leg is not healed. Standing will be agonizing, but lying still means being eaten alive. The choice is not a choice. The young adult Brachiosaurus roars. It is not the bellow of a calf. It is a sound that has been building in the animal's chest for 14 years, a sound that has never before been needed, a sound that is powered by lungs the size of wine barrels and resonated through a neck 30 feet long. The roar blasts outward across the hillside, flattening the grass, startling the ornitholestes so completely that 2 of them fall over in their scramble to retreat. The young adult surges upward, its 3 working legs propelling its chest off the ground, and with a convulsive effort that sends a visible shudder through its entire body, it straightens the broken foreleg and plants the hoof on the earth. The pain is indescribable. The fracture callus screams with a signal that the animal's brain can only process as emergency. But the leg holds. The woven bone, imperfect but sufficient, bears the load. The young adult takes 1 step, then another, its gait a 3-legged lurch that would look pathetic if it were not so terrifying. The ornitholestes scatter, their ambush broken. The young adult drives them away with its sheer, improbable refusal to die. And then, alone once more on the hillside, it lowers its head and rests, steam rising from its flanks in the cooling air. The young adult Brachiosaurus limps north over the following weeks, following the scent trail of the herd. It moves slowly, stopping often, grazing on whatever browse it can reach without straining the healing leg. The fracture continues to mend. The limp begins to lessen. By the time the young adult catches up to the herd, 2 months later, the break is fully bridged by bone. The scar will remain forever, a ridge of thickened cortex that will be visible in the fossilized femur when it is unearthed. But the animal is whole. The calf that hatched from a soccer ball egg, that survived the 85% mortality of infancy, that nearly died when its own neck grew too fast to lift, that stood against the Allosaurus pack and the superstorm and the drought, that broke its leg on a collapsing slope and rose again, that calf has crossed the final threshold. It will never be prey again. Year 15. The young adult weighs 40 tons. It is sexually mature. The last of the subadult growth acceleration has tapered into the slow, steady plateau of adulthood. The conflicting hormonal signals that nearly fractured its bones from the inside have resolved into a stable equilibrium. The animal will continue to grow for another 20, perhaps 30 years, adding mass at a much slower rate until it reaches its full adult weight of close to 80,000 pounds. But the dangerous part of the journey is over. The gauntlet has been run. The young adult begins to participate in the breeding cycle. Each dry season, when the herd gathers in the traditional mating grounds in the southern reaches of its range, the animal that once hid alone beneath a rotting fern log now stands among the dominant adults, its neck postures communicating readiness, status, fitness. It will mate. It will, in time, produce its own clutches of eggs, laid in shallow scrapes and abandoned to the mercy of the Jurassic. Some of those eggs will hatch. Some of those hatchlings will survive their first year. And somewhere in that long chain of generations, the legacy of the calf will continue, not as a conscious inheritance, but as a statistical reality written in the calculus of survival. The calf's life, seen as a whole, is a testament to a biological strategy that has no equal in the modern world. No living land animal grows from a 2-pound neonate to an 80,000-pound adult. No living land animal sustains growth rates of several kilograms per day for over a decade. No living land animal passes through so many distinct ecological niches in a single lifetime, from prey, hiding in the ferns, to competitor among the subadults, to titan that shapes the very landscape. The Brachiosaurus calf was not just an infant destined to become a monster. It was a survivor in a system that was engineered to kill it, at every stage, from every angle. And here is the thing that makes this story not just a paleontological curiosity, but a window into something deeper. The bones that tell this story are not just records of one animal's life. They are records of an entire vanished world, a world so different from our own that we struggle to imagine it. The Morrison Formation, where this calf lived and died, stretches across 13 states and 2 Canadian provinces. Its rocks contain the fossils of hundreds of thousands of animals, each one a life, each one a story like the one you have just heard. And almost all of those stories are untold. The science that reads the growth rings in the bones, that reconstructs the biomechanics of the neck, that traces the isotopes of ancient water locked in tooth enamel. That science is still in its infancy. We are only beginning to hear the voices of the Jurassic. The young adult Brachiosaurus lived for perhaps 30 more years after its femur healed. It saw the seasons turn, the rivers shift their courses, the predators come and go. It saw its own offspring grow from eggs to calves to adults. And when it finally died, of old age or disease or some catastrophe that left no mark on the bones, its body sank into the mud of a river floodplain. Sediment buried it. Minerals infiltrated its skeleton. The bones, the same bones that had grown from fragile cartilage into the architecture of a giant, became stone, and 150 million years later, in a museum in a world the animal could never have imagined, those bones are on display. A child looks up at them. A parent reads the plaque. And the life that began in a soccer ball egg, that nearly ended a dozen times, that triumphed over every obstacle the Jurassic could throw at it, continues its work. It teaches. It astonishes. It reminds us that the past is not dead. It is waiting, patient as stone, for someone to listen. The child in the museum does not know any of this. She sees the towering skeleton, the impossible neck curving through the atrium ceiling, the bones the color of old stone and older memory. She sees a monster. She sees a giant from a world that vanished before her ancestors ever walked upright. She sees something that seems unreachable, unimaginably alien, and that is fair, because the truth of what she is looking at is almost too large to hold in. A human mind. But the truth is not in the size of the bones. The truth is in the smallness of the beginning, and in the long, brutal, magnificent struggle between the beginning and the end. The calf whose bones these are, and they are the bones of a specific calf, not a generic Brachiosaurus, but an individual that breathed and ached and hungered and feared, died as an old adult, but lived eternally as a survivor. The scar on its right femur is a monument to a single afternoon when the ground betrayed it and its own body refused to quit. The thickened ridge on its 7th cervical vertebra is a testament to the weeks when it could not lift its head and yet found a way to drink from a puddle a stranger's footfall had just created. The microscopic lines in its enamel are a diary of droughts and floods, of migrations and mating seasons, of all the ordinary days that never became crises. This skeleton is not an exhibit. It is an autobiography, written in the densest, most durable language evolution ever devised. And it is not the only one. Every museum on every continent holds hundreds of these autobiographies. They whisper in the quiet halls after closing time. They tell stories of lives as rich and as fragile as any we have ever lived. The question that lingers, the one that kept me awake after I first learned these details, is not how the Brachiosaurus grew so large. It is how any of them grew up at all. The numbers are not just statistics. 85% mortality in the first 18 months. That means that for every 100 eggs laid, 15 hatchlings saw their second year. Of those 15, perhaps 5 survived the gauntlet of predators to reach subadulthood. Of those 5, maybe 2 made it through the neck crisis and the growth plateau and the risk of catastrophic fracture. And of those 2, One might live to stand on a breeding ground and pass its genes to a new generation of soccer ball eggs. The Brachiosaurus was not a species that thrived by protecting its young. It thrived by overwhelming the odds with sheer numbers, and by endowing each survivor with a body that, once it cleared the hurdles of adolescence, was nearly invincible. This is a reproductive strategy that feels to our mammalian sensibilities almost cruel, but it worked. It worked for over 100 million years. And that is the thing that I keep returning to. Whenever I walk through the dinosaur halls of a museum, the Brachiosaurus lived in a world that was, in every measurable sense, more dangerous than anything a large land animal faces today. The predators were bigger, the floods were more catastrophic, the climate swung more wildly, and yet the species endured. The bones of the Morrison Formation are filled with sauropods because sauropods, for all their apparent vulnerability as calves, were exquisitely tuned to survive their own world. They were not misfits or evolutionary dead ends. They were the most successful large herbivores the planet has ever produced. Their reign spanned the entire Jurassic and most of the Cretaceous. They were the baseline, the default setting for a large plant eater on Earth. For eons upon eons was a long neck, a fermenting gut, and a childhood spent running for its life. We are the anomaly. We are the fragile newcomers who have never known a world where the dominant life form towers 70 feet above us and shakes the ground with every step. But there is something else in these bones, something that transcends even the astonishing facts of their biology. It is the simple, stubborn fact of their existence. The Brachiosaurus calf that became the skeleton in the museum did not know it was part of a lineage that stretched back to the Triassic and forward to the eventual, catastrophic end of the Cretaceous. It did not know that its life, with all its struggles, would one day be reconstructed by a species of hairless bipeds who communicate through vibrating air and symbols on glowing screens. It only knew that it was hungry, or frightened, or tired, or strong enough to take one more step up the hillside. And it took the step. That is all. That is everything. There is a concept in paleontology that I find endlessly moving: the death assemblage. It refers to the collection of fossils found together, animals that died in the same place at the same time, their bones mingled by floodwaters, or drought, or predation. The Cleveland Lloyd Quarry in Utah is a death assemblage of Allosaurus. Dozens of them, jumbled with the remains of the herbivores they hunted, including young sauropods. When you look at those bones, you are not seeing a movie. You are seeing the final frame of 100,000 stories that ended in the same muddy basin, stories that began with eggs and hopes and growth and survival, and ended, as all stories end, with sediment and silence. The Brachiosaurus calf, whose life we traced tonight, almost ended there. It did not. It died somewhere else, at a different time, perhaps peacefully, its body settling into a river mud that was unusually kind, that lacked the scavengers and the currents that scatter bones. And because it died in the right place, at the right angle, with the right mineral saturation in the groundwater, we have its story. We can read it. We can be humbled by it. What do we do with that humbling? We can let it make us feel small, and maybe we should. There is a perspective that comes from standing beneath a sauropod skeleton that you cannot get anywhere else. It is not fear. It is not wonder exactly. It is a kind of deep-time vertigo, a sense that the universe is far larger and far older and far more creative than our daily concerns admit. But there is another response, and I think it is the one that drives people to watch videos like this one, to read books about deep time, to visit museums on weekends when they could be sleeping in. It is the impulse not just to marvel, but to connect, to see, in the life of a baby Brachiosaurus, something that speaks to our own experience. The fear of being small in a world of giants. The loneliness of finding your own path. the relief of discovering others who walk beside you, the pain of growth, literal and metaphorical, the satisfaction of standing at last on your own feet. The Brachiosaurus calf grew from 2 pounds to 80,000. It did so by eating ferns and sleeping in shadows and running from teeth and healing from breaks that should have killed it. It did not do anything that a human would recognize as brave. It simply followed the script that its ancestors had been refining since the dawn of the dinosaurs. But the script itself is brave. It is a script of relentless optimism, of betting everything on the long odds that growth and time can outrun predation and chance. It is a script that, against all reason, produced a creature that could look down on the tallest trees and see only more food. And when you read that script, you realize that the Brachiosaurus is not alien at all. It is a relative, a cousin, distant in time but close in the fundamental struggle to exist, to persist, to pass something onward. So the next time you find yourself in a place that feels overwhelming, a new job, a new city, a new challenge that makes your neck ache and your legs feel unsteady, you might think about that calf, not as a metaphor, but as a literal companion across the ages. The calf lifted its head when it could not. It stood when it could not. It healed when it could not. And it grew. It grew unimaginably into a giant whose shadow stretched across the Jurassic, into a fossil whose shadow now stretches across a museum floor. You are not a Brachiosaurus, but you share some of the same genetic machinery, some of the same bone-building osteoblasts, some of the same stubborn, unreasoning will to see tomorrow. That is not nothing. That is, in fact, the entire inheritance of life on Earth. If you enjoyed spending this time in the Morrison Formation, if you found something in the story of one small dinosaur's fight to grow up that stuck with you, consider subscribing to this channel. We explore these forgotten worlds every single night, not because they are escapes from our own, but because they are the roots of our own. Every dinosaur, every ancient ocean, every lost continent has a story like this one, and I would like to tell you more of them. Hit the subscribe button, leave a comment telling me what ancient childhood you would want to follow next, and, as always, get some rest. The Jurassic will be here when you wake. For now, let your own bones rest. You have grown enough today. Sleep well.